Hello everyone, welcome back to Let's Unbound. So I'm here with today with episode 7 of this particular playlist, sinusoidal function context and data modeling. So yes, this is about like real world applications, some real life context will be given and how we're going to solve and model uh, related with sine and cosine functions. Right, so let's get started. Be ready with pen and paper. Here we go. A sinusoidal function models periodic behavior. First, you observe something, and when you have to go for sinusoidal, when you notice a periodic behavior, and we already did the very first episode, it's about periodic phenomena. It repeats at regular intervals. And real life context like this, temperature changes over a day or a year, maybe the seasonal changes. Tides will have the periodic behavior, sound waves, Ferris wheel motion, voltage in AC circuits, and many, like phases of moon, all we did, right? So these are some real life context. We can see periodic behavior and we can model it with sinusoidal function. Now, how to identify the sinusoidal patterns in data? If your data repeats at regular intervals, a sinusoidal model is a good fit because that's what it is, right? Look for peaks, the high points, and troughs, the low points to determine amplitude. So when we model it, we need to make it an equation. So we need amplitude, then period, all this. Identify the interval between repetitions to find the period. Like if it's 0, 1, 2, 3, 4, and so on, and you've got this 1 by 2, 1, 0, and then again 1 by 2, 1, 0, something like this, you notice a periodic behavior, right? So go for peak, you see, and the troughs, you see, and you find amplitude, you can find the midline using this, and also you can find the period. So it's repeating after 2, right? So that way we can do. Okay. So very simple, basic of sinusoidal function. And here, constructing a sinusoidal model from data. So you know the data. How will you find an amplitude? Maximum minus minimum by 2. To find the period, 2 pi divided by the period length that we can observe from the data. That will contribute the value for B. If your model look like this, A sine, we already did this in previous lesson, right? X minus phase shift fits any there, you can do that plus B. For midline, you will use maximum plus minimum by 2 for D. And identify phase shift by comparing the data. Your original, the parent function with the one we are dealing. We should compare that for finding the C value. And D value is maximum plus minimum by 2. Very simple. So nothing new, but we are going to relate the math concepts with real life context. Here we go. So also it is used in various disciplines like physics, astronomy, biology, engineering, finance, and economics. Any kind of things we might get, but the thing is same. You notice a periodic behavior, repeats value at regular intervals, then go for amplitude, like maximum, minimum, that plays an important role, period, all this stuff, right? Now let's solve questions. The outside temperature over a day is modeled by this sinusoidal function, where T of t is the temperature in degrees Celsius and lowercase t is time in hours after midnight. What is the maximum and minimum temperature? At what time does the maximum temperature occur? So all I know is this is amplitude, midline. These are the ones which connects with minimum and maximum. So I'm going to use it. So your amplitude is 8. Let's solve this in next page. Here, 8 is amplitude and you can represent it by maximum minus minimum by 2 is 8 and this implies maximum minus minimum is 16. Then this gives maximum plus minimum by 2 is 20 and that will represent maximum plus minimum equals 40, right? So let me take this here and I'm going to solve for this. Okay. I want what is capital M, maximum and small m. So directly I can cancel this. M and M is 2m and 40 and 16 is 56. Your capital M is going to be 20, right? So what is small m? You can substitute in that. M is 40 minus 28, which is 12. right? And next one, M and M we did. So capital M is 28, small m is 12. That is maximum temperature and minimum temperature. At what time the maximum temperature occurs? So when your T is 28, what is lowercase t, the time? So you plug in this equation, you can plug in 28 equal 8 sine. You can take that, let it be here, pi by 12 t minus 6 plus 20. So solve for it, solve for small t. Subtract 20, you got 8 equal 8 sine pi by 12 t minus 6 plus 0. So I'm not writing that. And 8 will get cancelled here. 1, don't put 0. Sine pi by 12 t minus 6. The sine of what is 1, right? It's sine pi by 2, it's 1. Or you can take the sine here and it will be sine inverse, right? That way also it can be. So you will get pi by 12 t minus 6 equal pi by 2. Because sine of an angle is 1 means that angle is equal pi by 2. So pi cancel 1 times 2, 6 times. So you got 60 minus, no, not 60. So t minus 6 equal, the 6 will go here as 6. Add 6 on both sides and you got your t. T is 12. But they're asking us what time. Our model starts at midnight, 00, right? Midnight. 12 means so t equal to 0 this time. So t equal to 12 means it's noon, right? Noon, 12 noon. So at 12 noon, 12 o'clock, there will be a maximum temperature. Maximum temperature, right? This is the way we'll solve. And we are moving to, that's just 2 parts. Now question number 2. The height of a passenger on Ferris wheel is modeled as h of t is 25 cos 2 pi by 60 t plus 30, where h of t is height in meters and t is time in seconds. What is the radius of the Ferris wheel? How long does one full rotation take? Verify the model using the following data. Let's do one by one. Okay, a Ferris wheel will be like this, like a unit circle, or right? Okay, it will has a radius. We have to find radius of the Ferris wheel. Many points, or whichever point you connect, but it's quite difficult to find, right? So I'm gonna, if you from center to the maximum or minimum, I can connect because it's easy to get it from the information, like the model equation. So I'm gonna find what is maximum, right? Then radius is from like 0 seconds to the height. We can find it easily. So like 0 height. At 0 second, like it's 0 height if the person is at the bottom. So that is the way we are going to do finding maximum, and here we go. Actually, here's one thing. It's not just a general cos function, right? It's the cos function transformed one, and midline is 30. So the maximum should be calculated from 30. So 30, it's not 0. So y equal to 30, and it will reach maximum to minimum, like that it will go, right? So this is 30, and what is this point? It's my question, and then I can find the radius by subtracting them, right? So from this equation, how can I find maximum? Yes. The same thing as we did before. Amplitude is maximum minus minimum by 2, right? So maximum minus minimum over 2 is 25, so this is 50. From this, you will get maximum plus minimum equal to 30, but divide by 2, that will shift us multiply to 60. And solve for it. 2m equal to 110, m is 55. The maximum is 55. So going back here, if this is 55 and this is 30, this is 55 minus 30, which is 25. So the radius of the Ferris wheel is 25. Right? And also mention the units in the context modeling, it's meter, 25 meter. How long does one full rotation takes? It takes something, it deals with periodic nature. And I will go for this. Generally, it should be 1, right? B should be 1. But here it's 2 pi by 60. So, of course, there is a change in period and we can find it. How will you find the new period? New period is 2 pi by the B, right? So, 2 pi divided by 2 pi by 60. You will get 2 pi times 60 by 2 pi and cancel out 2 pi's. You got 60 and it's seconds. Something deals with seconds. So, the period is 60 seconds. For every 60 seconds, the pattern repeats. Right? So B part is done. Now last part is verifying the model. H of t is 25 cos t. Okay, this is the model. And when time t is 0, let me calculate. They said it's 55. So when t equal to 0, H is 55. Let's check. 55 equals 25 cos 2 pi by 60 times 0 plus 30. Okay, so let me solve this. 25 cos 0 is 1, right? So this entirely will become 0 and cos 0 is 1 plus 30. This side also 55. So it's verified. Do the same for t is 15. Your h have to be 30. Let's check. So I'm going to start 25 cos 2 pi by 60 times 15 plus 30. Let me simplify this. 1 times 30 times 1 times it's 2 pi by 2. So I know cos pi by 2 it's 0. So this term completely vanished and 30. Yes. When I plug in 15, I got 30. So this is also verified. The last part, t is 30, it is 5. Height is 5, I mean. So let's substitute 25 cos 2 pi by 60 times 30 plus 30. So 30, 30, 30 cancel. 25 cos pi plus 30. Cos pi is what? It's minus 1, right? So 25 times negative 1 plus 30, which is 30 minus 25 will get equal 5. That's also verified. So yes, this model perfectly aligns with the table of values given here. And also it's the equation. Everything is perfect. So it's the model is verified, right? And the third question, the population of a bacteria fluctuates between 4,000 and 10,000 over 24 hours period. The minimum occurs at 6 a.m. and maximum occurs at 6 p.m. Write a sinusoidal model where t is hovers after midnight. Use your model to estimate the population at 9 a.m. and explain your assumptions. Let's do one by one and let's understand what they actually say here. So we have to write a sinusoidal model. Should I go for sine or cos? Right. If it occurs at maximum or minimum, like if it starts at maximum, it will be a cosine function, like a cos model, right? So let's see. Minimum, I'm using small m, okay? Minimum is equal to 4,000. Maximum equal to 10,000. Period is 24 hours. Minimum occurs at 6 a.m. Maximum occurs at 6 p.m. Right? Now, let me make. So, if your model, like it's just, I'm gonna use sine or cosine model. So, here we go. Right, cos model or sine, let's see. First, let me find amplitude. Amplitude, like y equal to right. So amplitude, midline, all this we have to find. And okay, it is over a 24-hour period. So they said write your sinusoidal model that is after midnight. So midnight is 00, your time is 0. Okay. And 6 a.m. minimum occurs. So if it starts at minimum or maximum, I will go for cos, right? So t is equal to 0 and t equal to 6 a.m. Right? So we can go for cos model and let's see how we got here. Right? So y equal to a cos b times t minus c plus d, right? So how will you find a? Maximum minus minimum by 2, right? 10,000 minus 4,000 by 2. 6,000 by 2, it's 3,000. How will you find D? Maximum plus minimum by 2. We just add those. 10,000 plus 4,000 by 2 is 7,000. Period is 24-hour period. Actually, like to find B value, generally the period is 2 pi. Now our period is 24 hours. So we can solve this. It's pi by 12. Is the B value. And C is phase shift. Is there a phase shift? How can I find it? Usually we will start from the maximum, right? Like the cost function. If I pick the cost function, I will start from maximum. But at t equal to 0, it's not a maximum. So the maximum occurs after how many hours? Generally, your cost at times, like cost starts at maximum. Like when t is 0. At t equal to 0, I should have a maximum. But this time, at 6 p.m. only, it's maximum. Here, maximum at 6 p.m. So that is a phase shifted, right? Time is the horizontal component here. So t is 0. 6 p.m. means what time? The railway time, you know, right? It's 8 p.m. 18, I mean the time. T is 18. Okay, how I got it? This is midnight. 6 a.m. is 12 hours. So to 6 a.m. is 6 hours. Then 6 to 12, another 6 hours. Then 12 to 6 p.m. It's 18. So T is 18 there. Okay. So the horizontal shift is 18. So your C is 18. And we got everything. Let's write in. Your function model is something like this. Y equal to 3000 cos. B value is pi by 12. And T is the thing. Okay. Let me go with P of T, not Y, correct? So P of T is 3000 cos pi by 12 T minus 18. Okay, it's shifted. The maximum is shifted plus 7,000. Right, this is sinusoidal model I picked here. Now, use your model to estimate the population at 9 a.m. So at 9 a.m., what will be the respective T value? That is all you have to do. And it's quite easy. Okay, just a second. Okay, so t equal to 0, like midnight is t is 0. 9 a.m. means it's 9. So you just plug in t is equal to 9. Right, when we plug in this, we will get 3000 cos pi by 12. What is 9 minus 18? It's minus 9 plus 7,000. Next one. So we can just simplify this. 3000 cos 3 times, so negative 3 pi by 4 plus 7,000. Okay, if it's not a calculator paper, you should be able to find the values. So 3 pi by 4. I know cos pi by 4 is something 1 over root 2, right? So now minus 3 pi by 4. So cos of minus theta is this place and it's positive, right? So 3000 cos 3 pi by 4 plus 7,000. So 3 pi by 4 value is 3 pi by 4 will be here, 3 pi by 4 will be here. So this will be made into 3000 cos, like negative cos pi by 4, okay? Because 3 pi by 4 takes place here. And I know pi by 4, cos pi by 4 and sine pi by 4 same. It's 1 by root 2, right? So you can plug in that 3000 times negative 1 by root 2 plus 7,000. And rest we can go with calculator. So you will approximately get here as 4879 bacteria at 9 a.m. Okay, that's how this thing goes. And now the last part, explain your assumptions. So in this model, we made like I assume cost, right? Because it starts with I have a maximum information and like when it occurs those, right? So I go for that one. Now, let's list out some assumptions. So we are the population, right? Like from midnight, then it attains maximum, suddenly it goes to minimum value. So we are taking that as a perfect sinusoidal pattern. First we observe, all right? So population of bacteria follows a sinusoidal pattern. Perfect, not like random one. Population follows perfect sinusoidal pattern. It's not a regression and all, right? So we directly go for the perfect sinusoid thing. For 24 hours only, not after that. Over 24 hours. That also you can mention. And next is whatever our assumptions for this, minimum maximum occurs at minimum and maximum occurs at 6 a.m. This also plays a main role in constructing, respectively. Then, right. So also we did this. The rate of change is smooth and continuous. Like it doesn't matter at noon the bacteria got affected. Like there is no predators, right? So we are ignoring external factors. In real life, there it will be not smooth. There will be some problems, right? So we are ignoring external factors. Okay. And that's why it's completely constant. Having a rate of change is smooth and continuous. If you don't ignore it, will be different at different times. So these are our assumptions over here. And with this, we are completing the third problem. Yes, here is a bonus question. Take a screenshot and solve it on your own. This will be a good practice question, and let me know in comment section if you have any feedbacks or queries or doubts, right? So let's meet in next video very soon. Until then, keep learning, keep practicing. Here is my last formal dialogue. You can chat, you can join Let's Unbound Student Community by scanning the QR code here. Keep learning, stay curious. Bye.